yesterday was we finished A through D. Yes? Y'all both have a graphing calculator, yes? No. Don't. That's just spelling trouble. Now, we did these by hand, and we kind of saw how we can work them out either by hand or kind of logically, or kind of logicking our way through it. Because the logic way to do this is we're saying 4 to what power is 64? And we can go through and find the powers of 4 and try to work that out. In the graphing calculator, let's clear that. Clear the key history. First thing you want to do is turn it on. Then hit math. Scroll up or down to find log base. And the one we're looking at is log base 4, so we'll put 4, of 64. And once you get it, hit enter. So we're saying 4 to what power 64? Well, we're saying 4 to the third power is. So for this here, the one we did already, this would indeed be 3. And we already got 3, yes? Then to go to the next page. So let's look at these here. If I wanted to find log base 4 of 256, I come over to the calculator, go math, log base 4 of 256. And it tells us it is 4. So it's telling us that 4 to the fourth power is 256. And we can go math log base 8 of 0.125 is -1. Math log base. Now it says 1/3. Now we can do alpha y equals enter. There's a good chance, depending on the calculator, the 84s might give you that dark slash for fraction. So what you can do instead, if it's not really wanting to work with you, we can say 1 divided by 3, that is 1/3. Still gives us the exact same thing. Now once we've typed it at once, we can recall it and have it tell us what it is. Questions on how we found these here? And this works because nothing in any of these expressions is a variable. The variable, the unknown term, is what it's equal to. We just calculate it. Now we can't use the log button, the LOG button, because this one here, the base is understood to be 10. But the base is not written, it's understood to be 10. So like the last one, I can't do log of 8 because it's log base 10 of 8. That's not what we're looking at. Questions on these here? Natural logs work the exact same way as logs, but the base is understood to be E. I kind of have it a little bit flipped from how I have it written on your paper. It still works the same. Why not? I'll keep it as x equals y. If and only if e to the y is equal to x. So the natural log of 6 equals x. Even though it's not written, this base is understood to be e. So we have the natural log base e of 6 equals x. In exponential, we would have that base of e to what power? X is equal to? So this is the exact same as what we did with logs. It's just they're not telling us, they're not writing out the base of e. Natural logs, the base will always be e. If you see ln, it does look like in. ln, that base is e. So on this one here, we have e to the b is equal to 5a. When we have a product and no parentheses right next to a log or natural log, they're understood to be together inside the parentheses. If it had been written as 5a plus 1, the plus 1 is outside. If the plus 1 was inside the log, they would put parentheses. I dislike that it's just natural to understand that because there's no parentheses around the 5a plus 1, 5a is inside, 1 is outside. It's not that hard to go parentheses, but I digress. Let's look at the next one. Natural log of 42 plus b would be e to the b equals, what would the next one be? E to the 6 equals z. Now, if you notice on these here, I'm using variables instead of numbers across the whole thing, and it's for one reason and one reason only. E to the 6 is 403.4287935, ... It's an irrational number. And yes, I could say 403, e to the 6 is approximately 403. No, I want this to be an actual equation. We're not doing approximate. We're not doing rounding. Makes sense? So it's easier to just throw a variable in. All right, natural log of 4 to the y equals d. The exponential form would be e to the d equals 4 to the y. Doesn't matter that what's inside the natural log is 4 to a power, 4 to the y. Works the exact same way. Here's a funny one. Natural log of 3 to the a is equal to e. So we'd have what? E to the e equals 3 to the a. E to the e equals 3 to the a. Yeah. We can have e to the e. We could actually realistically have e to the e to the e. We can just keep putting it out because e is just a number. Questions on this here? Let's go the other direction. E to the y equals x if and only if the natural log of x is equal to y. Again, that e, that base e is understood. We don't have to write it. So for this first one here, we would have the natural log of what? Natural log of y equals 2x. How about the next one? Natural log of z equals 57. Are you ready for the next one? E to the 9y equals 6. So the natural log of 6 equals 9y. E to the b equals 4 would be the natural log of equals b. These two here are examples, because I said this yesterday, sometimes it's going to be better to have it in exponential than logarithmic. Sometimes it's going to be better to have it in logarithmic instead of exponential. Because e to the b equals 4. We're saying what power of b, or what value of b, will make e to that b power be 4? We don't know, especially since e is an irrational number. I rewrite it in logarithmic. We have what? The natural log of 4 equals b. Both calculators can take the natural log of 4. So 1.386294361 approximately is the value of b. So if we take e and put it to that exponent, we should get 4, or approximately. It's rounding, but here, having it as a logarithmic helps me actually solve it, where I couldn't get it as an exponential. Most of the ones here are fine where they are, but sometimes having it as a logarithmic doesn't help us. We need it as an exponential. Questions on how we rewrote these? Last set. We want to evaluate log of 8 and natural log of 3. Now, did they give us a base for log of 8? No, so it's understood to be 10, which also means I can grab either calculator and hit that log button, either one. And we'll say log of 8. So we had 0.903089987. It told us to round to 3 decimal places. So 0.903. Does the fact that the log of 8 is less than 1 make sense? Because we said when the base and what's inside are the same, log base b of b is equal to 1. What is our base for log of 8? 10. So log base 10 of 10, I'll write it here. This, according to that property, should be 1, yes? 8 is less than it. So that means it should equal less than 1, because we're saying 10 to what power is 8? It's got to be smaller than 1. Now, back to what we were looking at, natural log of 0.3 is negative 1.203972804, 3 decimal places, so that 3 is going to have to round up negative 1.204. Questions on either one of those there? We're ready for the next two. Log of 98 and log of 9.8. This is interesting. Log of 98 is 1.991226076. Yes? Come on. Mm-hmm. So, log of 98 was 1.991226076. Log of 9.8 was 0.991226007. Isn't that interesting? Because what did we do? Well, we divided 98 by 10 to get 9.8. We removed a factor of 10. Well, log of 10 is so if log of 9.8 is this here, what do we think log of 0.98 is going to be? because we took this and subtracted 1 because we're taking 1 away each time, yes? So let's go the other direction. I'm going to call this down again. Say we took, well, log of 98 gave us this. So what would be log of 980? Because we're adding a factor of 10, so we're adding 1 to it. We're going to get more into why this works tomorrow with our properties of logs. I have a feeling you all don't need to see how to type these two in. We got these two? Yeah. 5 through 8. Rewrite the logarithm in exponential. 11 through 14, rewrite the exponential and logarithmic. 17 through 20, evaluate each one of those. We can use the calculator or do it by hand. It's up to you. And 27 through 32 is use a calculator to evaluate those. And that's it.